Hey guys, welcome back to the laboratory. In this video, we are looking at bonding in metals. By the end of this video, you should be able to describe the structure of metals, explain the properties of metals, and explain the electrical conductivity of different metals. So, let's go. Metallic bonds are formed between metal atoms. These bonds are formed when metal atoms lose their outer shell electrons. The metal atoms become positively charged ions, and the electrons lost become delocalized and move freely throughout the structure. The electrostatic attraction between the positive metal ions and the delocalized electrons is the metallic bond. For example, magnesium is in group 2 of the periodic table, meaning it has 2 electrons on its outer shell. When magnesium atoms form a metallic bond, each atom will lose these 2 outer shell electrons. The magnesium atoms become Mg2+ ions, surrounded in a sea of their delocalized electrons. The attraction between the opposite charges and the repulsion between the like charges causes the particles to arrange into a giant lattice. This bonding can be used to explain the properties of metals. Let's start firstly with their melting and boiling points. All metals, except for mercury, are solids at room temperature. This is because of their very high melting and boiling points, which are a result of the strong forces of attraction between the positive metal ions and the delocalized electrons. Lots of energy is needed to overcome these forces and change the state of a metal. Therefore, their melting and boiling points are very high. The more outer shell electrons that the metal has, the higher its melting and boiling point. This is due to the increased positive charge on the metal ion and the increased number of delocalized electrons, therefore resulting in stronger bonding. For example, aluminium has a higher melting and boiling point than sodium. This is because aluminium has 3 electrons in its outer shell. When aluminium forms a metallic bond, it will lose these 3 outer shell electrons, forming an aluminium ion with a +3 charge. In contrast, sodium only has 1 electron on its outer shell, and will form a sodium ion with a +1 charge when it forms a metallic bond. There is a greater attraction between the aluminium ions and its delocalized electrons than there is between the sodium ions and its delocalized electrons. Therefore, more energy is required to change the state of aluminium, therefore resulting in a higher melting and boiling point. Metals are also great conductors of electricity. Remember, for a substance to conduct electricity, there must be charged particles that are free to move and carry the electrical charge. In a metal, these particles come in the form of delocalized electrons, which are freely moving and are therefore able to carry the electrical charge. Some metals are better electrical conductors than others. The electrical conductivity of a metal increases as the number of delocalized electrons increase. For example, sodium has 1 electron on its outer shell. When sodium forms a metallic bond, each sodium atom will lose this 1 outer shell electron. Magnesium is in group 2 of the periodic table, meaning it has 2 electrons on its outer shell. When magnesium forms a metallic bond, each magnesium atom will lose these 2 outer shell electrons. When comparing the electrical conductivity of these 2 metals, magnesium would be the better electrical conductor, as there are more delocalized electrons present to carry the electrical charge. Metals are also very malleable, meaning that they can be rolled and hammered into different shapes without shattering. When a force is applied to a metal, the positive metal ions slide across each other. The strong attraction between the delocalized electrons and the positive metal ions hold the particles together, therefore changing the shape of the metal and preventing it from shattering. Here's an example of a 6-mark past paper question on this particular concept. Take note of the fact that this is a 6-mark question, so your answer will need to be thorough and detailed to achieve the full marks here. Pause the video and take your time to answer. I'll be waiting for you on the other end with the mark scheme. This question can be split into 3 separate parts. You'll need to explain the structure of a metal, explain why they are malleable, and explain why they conduct electricity to achieve the full marks here. We'll start firstly with the structure. Metals consist of layers of positive metal ions arranged into a regular arrangement called a giant lattice. The lattice of metal ions are surrounded by a sea of delocalized electrons. Next, we can explain why metals are malleable. As we know, when a force is applied to a metal, the metal ions slide across each other. The delocalized electrons between the metal ions hold the ions in place, and so allow for the metal to change shape instead of shattering. And finally, metals are able to conduct electricity because there are delocalized electrons present that are free to move and carry the electrical charge. You'll notice that there are more than 6 points for this answer. More often than not, the mark scheme for a 6-mark question will have more than 6 points that a student can give to achieve the marks. So be sure that your answers to these types of questions are detailed and follow a logical structure. So, how did you do on this question? Let me know in the comment section below. Anyway, that's it for this video, guys. Thank you for joining me in the laboratory. Please leave a like on this video if you found it useful, and don't forget to subscribe to the channel so that you don't miss another one. See you soon!